Okay, so we're back and we're going to do another problem. And I didn't realize how long this was going to take, and it's kind of late. So this might be a one problem or two problem video, and then we can come out with some other stuff tomorrow. But we just did 6, and do I like this one? Kinetic friction. Oh, I didn't actually go over friction, so let's actually do that real quick. So this will be a friction video and a problem. So we're going to talk about friction. Now again, or you might be watching this for problems, but I will just go over the ideas because it can't hurt. So we got 2 types. So we got 2 types. And then we're going to write our kinetic and static. Okay. I'll try to keep this relatively brief. And let's note that the friction coefficient is, nope, that looks ugly, mu. It's spelled mu. Kind of writing it a little poorly. That's a little better, I guess. I never wrote it great. But yeah, that's the idea. So what we're going to do is just quickly go over static friction. We got static friction. And this is, I guess there's not even much to talk about, really. What we can say is that we denote this with mu sub s, obviously the coefficient of friction for static. And this ranges from, way we can write this is it ranges from 0 to Fs max, where that is the force of static friction, and that's the max value, obviously. And then our Fs max is equal to mu s Fn, where we have our contact force, contact/normal force, and then our coefficient of friction. I realize a little now, this might not be the greatest explanation, but it is a relatively simple concept. So for now, kinetic friction, did I get those colors right? I did. Okay, cool. We just say, well, I guess we'll write the denotation. It's mu sub k, and then we say that F mu sub, or Fk, you don't say mu sub k, just Fk. That's the force due to friction, obviously. Kinetic friction is equal to mu sub k and times the contact force. And yeah, okay. So real quick, we'll just go over a little example. I'll say we have a box. This box is 50 kilograms, and it's on a floor of some sort. Can't draw a nice line. And our coefficient of static friction is 0.5. Our coefficient of kinetic friction is 0.4. So our first question is going to be, okay, actually we'll just move this to a new page. We got a box, and we're going to ask, we have a 200 Newton force to the right. And then we're going to be asked, calculate acceleration. So let's draw our free body diagram. It's always very important. So we have 50 kilograms, that would be mg acting downwards. I'm not going to put in the values quite yet. As a result, we have our contact force acting upwards because it's just on a normal plane. Now we have a 200 Newton force to the right, and as we know, this plane has friction, so we have to determine, this is the whole question, we have to determine if this block actually moves, and that is to ask, is Okay, we're going to write this is Fs max, right, greater than, I guess F net. Yeah, that's the idea, at least. And then if that's true, no acceleration. And then so if you're rooting for the box, you're going to want this 200 newtons to exceed the force due to static friction, and therefore it's just going to move. So what we're going to have is we need to calculate the contact force. Fn equals mg, which is equal to what was it, 50 times 9.8, which is equal to 490 newtons. So our, right, I actually forgot to show friction as our force due to friction. Now we know what the contact force is equal to, so we're going to write our Fs max is equal to mu sub s Fn, and that will be, what did we give a value of? 0.5 times 490, and that would be 245 newtons. So since Fs max is greater than I guess the force applied, maybe that's a better way of putting it. Yeah, we'll just call it that, I guess. Therefore, the box doesn't move. So sad. Now, I won't go through another example, actually. But if we say that this force was 250, then it would be greater than, and what we would see is that the static friction wouldn't be a part of the equation, like literally, and we would have to use kinetic friction. So let's do a problem. Let me try to find a good one. I gotta scroll up, and I guess we'll just do 7. No horizontal 4. Okay, I mean, sure. I feel like this is a simple example if I read that right, but it's okay. So let's scroll back down and paste. Cool. So let's highlight key information. When a horizontal force of 300 newtons is applied to a 75 kilogram box, the box slides on the floor. We know it moves. And is posed by kinetic friction of 120 newtons. We want to find the magnitude of the acceleration. Okay, so free body diagram, easy. We have a 75 kilogram box, and it's I guess it technically doesn't say direction. I'm just going to say right. This is going to be 300 newtons. We're going to have our mg downwards, and we're going to have our Fn up. And we're also going to have our force due to kinetic friction there. So first, let's calculate Fn. Say Fn is equal to mg. mg is equal to 75 times 9.8. 75. Wait a minute. This problem is much easier than we need, right? I think I was. Well, maybe we'll twist it a little bit. Kind of just assumed to draw a free body diagram. But I think all we need to know is find F net. So I'm gonna do a little sub thing here and say F applied minus F kinetic is equal to 300 minus 120 is equal to 180. And then we're going to say F equals MA, 180 equals 75A, then A would equal 180 divided by 75. That would be 2.4 meters per second squared. If that is the answer on the answer key, I don't know. Yeah, that's the answer on the answer key. Okay, so maybe this problem was a little easy than I read into it, but what we're going to do is append the question to I. What is the coefficient of what is mu k? And that is what we'll find. And we should be able to do that. Yeah, definitely should be able to do that. So we're going to keep on going with this contact force. So 75 times 9.8, that would be 735 newtons. Now we know this kinetic force is equal to mu sub k Fn. We don't know mu sub k, so we're going to rearrange this a little bit and say mu sub k is equal to F sub k over Fn. Now our force due to the kinetic friction is equal to 120, and our contact force is 735. So we have 120 over 735, which is 0.163. And that doesn't have a unit, it's just a value. So we have our two answers, one a little easier than the other, but they both weren't bad in all honesty. That's gonna be it for right now. We'll do more problems tomorrow, so I hope you enjoyed, and I'll see you later.